Okay, let's work through our first example in our mass-to-mass conversion guided practice. Calculate the mass of carbon monoxide needed to completely react with 50 grams of iron 3 oxide. So if I look at my mole road, I am giving you the mass of iron 3 chloride, and I'm asking for you to find the mass of carbon monoxide. This problem is going to require you to go through 3 steps. We need to convert iron 3 oxide into moles of iron 3 oxide. We need to turn moles of iron 3 oxide into moles of carbon monoxide. And then finally, we need to turn moles of carbon monoxide into grams of carbon monoxide. Let's go ahead and highlight what we were given and what I'm asking you for. I gave you 50 grams of iron 3 oxide. And I am asking you to find mass of carbon monoxide. If you see the word mass, mass is referring to the number of grams. All problems start out the same way. You should write down your given, which is 50 grams of iron 3 oxide, and then draw a railroad. Looking at our mole road, the first thing we're doing is turning that into moles of iron 3 oxide. I need the molar mass for that. So let's get out our calculators. Iron has a mass of 55.85 times 2, plus oxygen has a mass of 16 times 3. I have a molar mass of 159.7 grams of iron 3 oxide in 1 mole of iron 3 oxide. At this step in my mole road, I'm at moles of iron 3 oxide, and I want to turn that into moles of carbon monoxide. For that, I need my mole ratio, and those numbers come from the coefficients in my balanced equation. There's a 1 in front of the iron 3 oxide, and there's a 3 in front of the carbon monoxide. 1 mole of iron 3 oxide needs 3 moles of carbon monoxide to react. If I stop here, I would have a final answer that's moles of carbon monoxide, but I need to keep going to find the grams of carbon monoxide. And to do that, I need to multiply by the molar mass. Carbon has a mass of 12, oxygen has a mass of 16. The molar mass is 28 grams of carbon monoxide in 1 mole of carbon monoxide. To get my final answer, I multiply all of my numbers on the top. So 50 times 1 times 3 times 28, 4,200. And then I multiply across the bottom, which is 159.7 times 1 times 1. I'm going to divide 4,200 by 159.7, and I have a final answer of 26.3 grams of carbon monoxide. Let's take a minute to look over our problem and identify where all of those numbers came from. We started with 50 grams of iron 3 oxide. That was my given, and I got that number from the problem. The next number I see is 159.7. That is the molar mass of iron 2 oxide. The third number I see is the 3 and the 1, and that is my mole ratio, which comes from the numbers in the balanced equation. If there's no number in front of a compound, you can assume it's an imaginary 1. And then finally, the 28 is my molar mass of carbon monoxide. because my final unit is grams, that's going to be the final unit in my answer. All of the other units canceled out, and I'm left with grams for my final unit.